Hope you're having a good day. Thank you for studying math with me and watching this video. Today's topic is rational exponents. A rational number is a number that is a over b, where a and b are integers. And so here's the first example. And we're talking about negative numbers. So if I say 10 to the minus 3, that means that is 1 over 10. So the answer to that example will be 1 over 10 cubed. 10 to the minus 3 is 1 over 10 cubed, and that would be 1 over 1,000. Now here the exponent is minus 1 and the base is 5. So the 5 is the thing that's put in the denominator. The minus sign is in front. So minus 5 to the minus 1 is minus 1/5. And the last example on this page is if I have 4 over 9 to the minus 2, it's inverted, 9 over 4 squared. And when I do the calculation, I will get 81 over 16. Continuing with examples about negative exponents. Here the base for the exponent minus 4 is n, so that's the only thing that goes into the denominator. So that would be m over n to the fourth. Here the exponent is minus 4, but the base is the product of m times n, the whole parentheses, and so I would have 1 over m to the fourth and n to the fourth. If you have the same base in the numerator and the denominator, and an exponent of 8 up here and 3 up here, you're going to be subtracting exponents. So 8 minus 3 is 5. So this one is going to be 15 to the 5. Here we're going to have 35 over 25. That's a number. In lowest terms, there's a factor of 5 in each one. And here we're going to have r to the 6th minus a minus 4. And so that is going to be r to the 10th. So this is going to be 7 over 5 r to the 10th. And and up here we had 15 to the 5. 7 over 5 r to the 10th, and here we're going to reduce this fraction. There's a 17 in 34, and there's a 17 in 51. We're going to subtract the exponents. If I have a to the 8 minus 12, that's going to be minus 4. That means I'm going to have a to the 4 in the denominator. And here I have 11 minus 5 is going to be 6. So I get 2b to the 6th over 3a to the 4th. And here I have y to the same base, y. So what I'm going to do is 4 minus a minus 9 is 13. Here's another example. This minus 3 as an exponent is applied to all of these factors. So I'm going to take minus 3 times minus 1, and that's going to be a positive 3. So this is going to be 2 cubed. And this is going to be, I multiply these, this is going to be x to the minus 12. So it's going to be x to the 12th in the denominator. But I have an x cubed in the numerator, so the net of all that is going to be an x to the 9 in the denominator, and 8 times 5 is going to be 40. So here I went through that calculation and got 40 over x to the 9. A similar kind of thing is going on with this example. There's a factor of 15 in each of these. Take 15 into that twice, 15 into this twice. This is going to be r to the minus 10, and here we're going to get s to the negative 12. So it's an answer of 2r to the 10th over 3s to the 12. In this one, we apply the exponent of minus 2 to each of these factors. That's going to be 1 over 16, and that's going to be b to the minus 6. I apply this minus 3 to each of those factors. That's going to be 1 over 4 cubed, and this is going to be b cubed when I multiply those exponents. Down here I'm going to have 4 to the minus 1 minus 4 is 4 to the 4, and this is going to be b to the minus 12. Now b to the minus 12 in the denominator is going to be a b to the 12 in the numerator. So the steps would be as follows. This is pretty much what I talked about. I'm calling 4 cubed 64 here, and 4 to the 4th is down there. That's b to the minus 12. That's going to go to the numerator soon. So it's going to be b to the minus 3. See, I have b's here as well. So that's what gives me b cubed over b to the 6th is b to the minus 3. If I multiply those two numbers, I get 1024. That's the denominator in the numerator. And here I have 256. That's b to the minus 12. This is going to be minus 3 minus minus 12. It's going to be b to the positive 9 all over. And if you do this arithmetic, you get 4 to the 9th power. Now, when we do a fractional exponent, what happens is a to the 1 over n, here we go, a to the 1 over n is the nth root of a, and we'll talk more about this as we go on. But here, and that's, so here we have 49, so that's the square root of 49 is going to be a positive 7. That's the principal square root. Here, the exponent is 1/2, but the base is what's inside the parentheses, 144, so it's the square root of 12, principal square root of 12. Principal square root of 144 is going to be 12 times minus, and so the answer to that is minus 12. Now here I'm trying to take the 6th root of a minus 64. This is going to have no real solution because there's a negative, and I'm trying to take an even root of a negative. Down here I have a negative, but I'm taking an odd root, so this is the cube root of minus 125, which is going to be minus 5. Similarly, on the other side, we have the exponent as 1/2 is applied to the 144, so this is going to be minus 12. Here, the 6th root of 64 is 2 to the 6th is 2. The 6th root of 64 is going to be 2 again, but the minus is in front. That is minus 2. And here the cube root of 64 is going to be 4, and the minus is in front of that, so that is minus 4. Now, that example focused on having a to the 1 over m. Here we're having a to the m over n. And so we have 81 to the 3/4 power. The way we do that is we take this, the 4th root of 81, which is known to be 3, and then I cube it. 3 times 1/4 would be the 3/4. So I get 3 cubed, and that's going to be 27. In this example, we have 25 to the 3/2. So I take the square root of 25, which will give me 5, and 5 cubed is 125. Now down here, I'm going to take the square root of 4 to be 2. 2 to the 5th is going to be 32, and there's a minus sign in front, so we get negative 32. Some more examples of that. Here I'm going to take the cube root of minus 64, and then I'm going to square it. So the cube root of minus 64 is going to be minus 4, but when I square it, I'm going to get 16. Here I'm going to take the cube root of 216. The minus in the exponent means it's going to be in the denominator, and then I'm going to square that number. So the cube root of 216 is known to be 6. So this becomes 6 to the minus 2 is 1 over 36. And here I'm taking the square root of a negative number, and that's not going to be real. The expressions can get a little more complicated. Here we have this expression. I'm going to apply the 2 to each factor, and here I'm going to apply the 1/3 to each factor, and what we're going to get is that 5 squared is 25. If I take 2 times 4 over 3, I get 8 over 3. 2 times 2/3 is 4 over 3. Over here I take 1/3 times 4 to get m to the 4 over 3, and down here I take the cube root of 8. The cube root of 2 is 8, and the cube root of n to the 5th is going to be n to the 5 over 3. So then I multiply across. Here I'm going to be adding exponents because m to that number times m to that number. I add exponents. That's going to be 12 over 3, which is also 4. And down here I'm going to be adding these exponents. That is going to be n to the 9 over 3. So at the end of the day, I get this number, 25m to the 4th over 2n cubed. Similarly here, what I can do is I can distribute this. When I take this times this, it's going to be 3 over 7 plus 4 over 7 is going to be y. When I take this times this, that's going to be 14 over 7, or that's going to be squared. The minus sign stays intact. And so I will have y to the 1, and this is y squared, and that's the answer to that problem. Let's look at this. The base everywhere is 18, so I'm going to be adding the exponents up here, and I will get 1 and 7 is 8, divided by 2 is 4, and the cube is there. I will subtract exponents then. I will have 18 to the first, or 18. The second example is going to be, I'll take the square root of 100 to get 10. 10 cubed is oh yeah, I'll take the square root, get 10. 10 cubed is going to be 1,000. But then here I'm going to take the fourth root of 16 being 2, and when I do that, I'm going to have 2 to the minus 3, put it in the denominator. So this is going to be 5 cubed, or 125. Down here, 5 times 4 is going to be 20. And now I have 3/4 plus 2/5. I need a common denominator. That means it's going to be 15 over 20 plus 8 over 20. That's going to be 23 over 20. And so the answer is 20z, 23 over 20 as the exponent. Here the directions say we want to factor out the least power of the variable or variable expression. So when we have here, we're looking for the least power. Now the least power is going to be the most negative number here, so I'm going to be factoring out y to the minus 5, and there's a common factor of 7 there. So if I factor out y to the minus 5 on that one, I guess I'll do it this way. I will factor out the 7 and the y to the minus 5. So what is left in the first term is a 4, because if I take this times this, I'll get 28y to the minus 5, and if I take this time, and I factor it out the second, if I take this times this, I will have 21. I'll add the exponents, and that's y to the minus 2. So the answer to that would be this, factoring it out. This happens a lot in calculus. Down here, I'm going to factor out the n to the 1/3, and there's also a factor of 6. So I factor out 6 into the 1/3, and that is going to be then times 3n minus 2. And with this one, the smallest one that I can factor out is the minus 2/5. So I will factor out the x plus 3 to the minus 2/5, and what is left is 1. And then this is going to be a minus sign, but then this, when I factor that out, is I'm going to be subtracting x plus 3. But if I distribute the minus sign, I get minus x minus 3. So you see this simplifies into minus 2 minus x, and so I can factor out the negative. I can put that different places. So the answer either could be written this way or this way. Nearing the end, this is the last example. We want to write our results only with positive exponents. So what I'm going to do is I'm going to call this 1 over x, this 1 over y, this 1 over x squared, this 1 over y squared. So that's what I do to start with. Now I get a common denominator up here. The common denominator is going to be x times y. And so here I'll multiply top and bottom by y. Here I'll multiply top and bottom by x, so I get y plus x over xy. Down here, the same kind of thing. The common denominator is going to be x squared y squared, so I'll multiply top and bottom by y squared here, minus top and bottom by x squared here, put it all over the common denominator. Now what will happen then, though, y squared minus x squared will factor into y plus x times y minus x, y plus x over xy. So what will happen is this is xy squared, this is xy to the first power, so this will cancel with one of those factors, leaving me just with xy in the denominator, and this y plus x will cancel with this y plus x, leaving me just with y minus x. So what I will have then is a net of 1 in the numerator, and in the denominator of the denominator is xy. So if I do that division, I get as a final answer xy all divided by y minus x. Please remember, time is precious. Each day must count. Do the math. It will make you strong. Take care.